It'd be cool if you guys could spread a little bit so you're not shoulder to shoulder, just to keep a little distance.
Which unit should I be in?
What's that?
Which unit should I be in? Because it's saying now saying the PSCSU one hasn't started.
Right.
958 3987 4646.
Are you ready to go?
Yeah. Let me join the webinar.
Kristen, just record this computer or
Ready?
and I'll do this by yourself.
I can't screen share, but it should be fine because we have the recording of the screen. So
Cool.
Okay, sure you start and stop it. Okay.
All right, so let's go. Welcome to our 2021 IT Bootcamp. This is our fourth bootcamp, fourth or fifth, actually, if we count the PSML. So we start with Mark Gross from Saddleback. Talk about command line interface. Please take over.
all right. Hello, everybody. Welcome. So, like Dr. Brigati said, my name is Mark Gross, and I'm a mathematics student at Saddleback, and I'm also currently a software developer at Roland DGA up on Bronco Parkway here in Irvine. I've been programming since about 2016, and I've been using Linux as my kind of daily driver since 2018. So this presentation is mostly going to be on the Linux command line. There are, let me start with my slides, I'm getting off track already. So really what we're trying to do with this presentation is, first I want to show you how the command line can be powerful and why you should even care about using it. And then secondly, I'm going to give you an introductory knowledge of how to actually use the command line to get things done. So there are basically two real reasons to use the command line. Number one, like I said, it's powerful. There's a quote from a book that I'm going to link at the end of this presentation that says, graphical user interfaces make easy tasks easy, and command line interfaces make difficult tasks possible. And that's very true. A graphical user interface is something like Windows Explorer or a web browser, where it's easy to use. You can open it up and with no prior knowledge, you can kind of figure out how it works and get some basic tasks done. But for more complex tasks, especially if you're operating on, say, batches of data, the command line is really going to be a more powerful tool to achieve what you want to achieve with that. And number two, it's everywhere. As I understand, most of you are probably physical sciences students. So you're most likely going to be working with a lot of data sets if you're doing research. And let's say one of those data sets is on a server. Let's say you have some server somewhere collecting data from a bunch of sensors, and you need to aggregate and do operations on that data. When you connect to that server, you're not necessarily going to have all those graphical interfaces. You might only have a command line. So every server, pretty much, in order to run and in order for people to administrate it, it needs a command line. So the command line is the one thing that you're pretty much guaranteed to have no matter where you go. So before we kind of get into the details, there's some quick terminology. The terminal and the shell, these words are kind of used interchangeably, but there are some subtle differences between them. The terminal is the actual graphical program that displays text and receives keystrokes from the user. So if we look at what we were looking at when you came in, this is a terminal, right? It's the actual graphical application that renders these characters. Restart slides. Then the shell is kind of the back-end program that takes the text that the terminal gives it, interprets that, and then runs it as a command, and then also maybe spawns some more programs. And to spawn more programs, it has to talk to the operating system. So the user talks to the terminal talks to the shell, and then that talks to the operating system. Then the operating system gives something back to the shell, and then the shell gives it to the terminal, and the terminal prints that out, and that's what you see on the screen. So from the shell's perspective, we kind of have this operation loop, right? You start the shell, and the first thing that happens is it starts waiting for you to type something and press enter. Then once you press enter, it tries to interpret that as a command and run it, and then it sends output back to the terminal, and the terminal renders it for you. So we can actually look at that right now in real time. Let's see if I can. 2, 4, there we go. So if we right now I've just started the shell, right? So all it's doing is it's waiting for me to type something. So if I type in a command, I'll type ls, and we'll go over exactly what that does later. Let's type cd. Right, there's no output there, but if I type ls now, there's the output, right? That's all the files in the directory that I'm currently in. And we'll go over files and directories and all that stuff, what's actually happening here in a bit. But we type command and it gives us an output. So, like I mentioned, in this talk, I'm mostly going to focus on the Linux command line, but there are also command line interfaces for Windows and OS X. So for Windows, we have command prompt or Windows terminal. I think Microsoft is kind of moving away from command prompt and kind of making Windows terminal the new command prompt. There's also PowerShell, and PowerShell I don't have too much experience with, but I've heard it's very powerful. It leverages the .NET framework, so it's kind of half shell and half programming language. And then there's also Windows subsystem for Linux, and that would run a shell called bash. And so Windows subsystem for Linux, it actually allows you to use basically a Linux shell on Windows. So a lot of people I know who need to use Windows for development, but also like the Linux command line, they use WSL, as it's called, Windows subsystem for Linux. And that gives them a great blend of the Windows exclusive programs that they need to use, and also the Linux command line. And so finally, for Linux and OS X, we have, honestly, a million shells are out there. But the three most popular ones, as far as I know, are Bash, ZSH, and Fish. And Bash is the kind of the shell of Linux. That's the one that's going to be there pretty much wherever you go. So let's look at kind of the anatomy of a shell command. So first off is we have the prompt. And the shell that I just showed you actually doesn't have that prompt because it's the shell that I customized. But if I start just bash, so here's our prompt. So the prompt describes who and where you are, basically. So this JDoe right here, that would stand for John Doe. Convention with Linux machines is usernames are going to be the first initial of your first name and then your entire last name. So JDoe is just the user. It's the person that's currently logged in. And then at Linux is going to be the host name of the machine. So on my computer, you see my username is Mark, and it says Mark at Samaritan, and that's what I named my laptop. And then after that, we're going to have the command, which is the application that we're telling the shell to run. In this example, we have that ls command that I just showed. After the command, we have short and long options. And the short and long options, they tell the command, they give it some more directions on how to run. Let's say, so ls, I'll tell you right now, like I mentioned earlier, it lists all the files in the directory. So we can give it some options. Maybe we'll want to tell it to list all the files, so include the hidden files, or maybe that's what -a does. -l, it lists it in long format. So if we go back to our example, we run ls, right? It just gives us the all the files kind of on one line. ls-l puts them all in a new line and gives us more details, right? These are file permissions. I believe Dr. Bagali has the next presentation, and he's going to go over more of the file system and the permissions. This number right here is, if it's a directory, it'll tell you how many things are in that directory. These two are the user and the group owner. Again, that's something that is more file system related. This number right here is the size of the file, and then we got the date and time it was created, and finally the name of the file. So I can add one more option, and if I say ls-la, there we go. Now, there's not too much to show because I don't have too many hidden files in this folder, but you see we have this new file that begins with a period, and it's tilde lock.cli.odp. That is a temporary file just created by my presentation software because the presentation is currently open and I'm editing it right now. I mean, I'm presenting it, but theoretically I could be editing it. So it's hidden because it has a period at the front. That's pretty much as simple as hidden files get in Linux. On Windows, you would go into the file's properties and maybe check a box that says this file is hidden. On Linux, it's as simple as just adding a period to the beginning. And then we also get these two entries, 1 period and 2 periods. 1 period represents the current directory, where you are right now, and 2 periods represents the directory immediately above you. So if we, wait, I was already there. So you can see we're in UCI slides, and if we do CD, which stands for change directory, and that's how we move around the file system. If we do CD ... it'll take us up 1 directory to my Git directory, and this has all of my Git repositories in there. And Git is, I'll be presenting on Git tomorrow. It's just a project management system. So if we cd back into UCI slides, now we're back here. And then finally, we have arguments, and arguments will tell the application what to operate on. There's not really one specific definition for what an argument can be, because it'll really depend on the command. In the case of ls, we can give it a list of files, and it will operate on those files. But let's say there's a command that takes a subcommand. A subcommand would be an argument. So for instance, there's a program called playerctl. I believe I have it installed. And it's used to basically control music on Linux machines or other media players. So if we run it, we get some information on how to use it. Let's see if I can scroll up and show you. So you see right here, it says available commands. Play, pause, stop, next, and previous. So that would be one of the arguments. We say stop. It says no players found because I'm not listening to music right now. But stop would be an argument to playerctl telling it what subcommand to run. And then, so I mentioned short options. Long options are essentially the same thing as short options. It's just how you actually type them. It's a longer name, and maybe you specify an argument to it. So it's a more explicit way of telling what the argument is. So in that example, we are telling it to always make the output colorful. So there are two useful commands for kind of finding your footing if you don't know what a command does. These are the two commands you can use to help you. So these are the only two commands you have to remember. Every other command, you can use these two commands to find out about it. So if I want to know more about the ls command, I can type man ls, and man stands for manual page. And that gives us this manual page for the ls command. So first it gives us the name and a short description. Gives us a synopsis, and the synopsis is basically how you would actually call that command on the command line, and a description. And the description will also list all the different options that we can use with this command. So we got all, which I showed, author, which I'm not sure what that does, escape. I'm not sure what a lot of these do, because there are quite a few options. As you can see, we got pages and pages and pages. So that's what man does. And then what is gives you a super short description. List directory contents. So if you just need the Reader's Digest version, a quick description of what a command does, that's what is will get you. All right, so working with the file system, I kind of showed most of this already. This is mostly just a command reference. So ls stands for list. We list the files or directories in a current directory. cd is the change directory. mkdir stands for make directory. mv is for move. rm is for remove. ln is for link. So if we go back to that where we were, so if we ls-l, there's all of our files. There's another command called touch, and that'll just create an empty file, touch file. Now you see we have a new file, and that's 0, it tells us that it's 0 bytes long. mv, the move command, is also used for renaming. So if we want to move the file to renamed file, now that's renamed it, right? And then if we want to get rid of it, rm, renamed file. And then I showed cd earlier, cd in this directory, list everything in there, cd back, and that's that. That's how we move about the file system. And then ln for linking, that's not too relevant at kind of an introductory level, but you can think of those like shortcuts in Windows, right? It's just a file that points to another file. Oh, and by the way, at any time, if anyone wants to raise their hand and ask a question, that's totally fine. I'm also going to try to check in with the Zoom chat as often as I can. In case you guys want to ask questions there.
I have a question. You're running commands, where do they come from?
So the commands are stored on the Linux file system. So let's see, I get lost in my terminals. So this ls command, if I type it right, so you can actually type in, there's a command called which, and if I type in which ls, that'll give me a file path to where that file actually is on my system. So I can say ls-l/user/bin/ls, and that's the actual file that runs it. So you can see it's about 141,000 bytes long. So that's our executable. And you see this X here. Again, that's something that Dr. Bergali will go over more in his file system presentation. That X means that it's an executable file. So it's something you can run. All right. So where the shell gets really powerful is what are called expansions. So let's just start with an asterisk, which is the wildcard expansion. And that'll match files in the current directory. So if I, let's see, we're right here. So if I type ls-l, we get all these files, right? So what if I only want to list the PDF files? You see, I got my two presentations, the CLI one and the Git one. Both, I have the actual presentation file, and then also I've exported them as PDFs. So let's say I only want the PDF files. I can say ls star, let's keep the -l, star.pdf, and that'll just show me the PDF files. Same deal, I can show just the ODP files, which is the presentation format. There we go. And I can do it backwards. So I can say, what if I want only the files that start with CLI? I can say ls-l, CLI star, and there we go. We got the ODP and the PDF file. So wildcard expansion is for matching files. Also, an important command for kind of debugging and exploring the shell is echo. Echo will basically just give you back whatever you give it. So if we say echo hello, it gives us back hello. And it might not seem too useful, but it'll expand what's on the shell first and then give that back to us. So if I say echo star, that gives us all the files in the directory. If I say echo star.pdf, it gives us all the PDF files. So what's really happening when I say ls-l star.pdf is the shell is interpreting that as ls-l git.pdf cli.pdf, right? So the star actually expands before it actually runs the command, it expands whatever's on the shell and interprets it that way. And then next up, we have range expansion. And so this, we can pass it two numbers and it'll expand to every number in between those numbers. So if I just type in echo, curly brace, 0 to 5, it gives us 0, 1, 2, 3, 4, 5. And we can combine that with text. So let's say we want to create 5 files labeled file 0, file 1, file 2, file 3, file 4, and file 5. We can say echo file 0 through 5. And there we go. It gives us 6 files named file 0 through file 5. Next up is set expansion, and set expansion is very similar to range expansion, where instead of giving it 2 numbers and it prints out every number in between, we just give it a set of items, and it'll do a similar thing, but instead of numbers, it'll do it with those items. So if we say echo file A, B, C, there we go, file A, file B, file C. And then finally, we have arithmetic expansion, where that's a $sign and 2 parentheses, and that's basically just how we do math in the command line. So you can use it as a quick calculator if you want. You can just say echo 5 plus 5, and it gives us 10. All right, so now we're going on to input and output. And so one of the critical, I'm going to skip ahead a slide. One of the critical things with the Linux shell is that each program can take some input and also give some output. So the output of one program can be the input to another. So there's this thing called the UNIX philosophy. This is a very much abridged version, but the 2 tenets that are really important for this presentation is that each program should do only one thing, and that the output of one program can be piped to the input of another. So if we go back to our command reference, so cat will concatenate files, echo, as I showed, gives the argument right back to you. Grep is something we can use to search for a pattern in a file or just a stream of output. So we can, if we pipe the output of ls into grep, let's check what we did before. So we have ls-l. So this gives us 5 lines of output, right? But what if we want to filter these lines? Or what if, let's say we had 100 lines and we wanted to filter them to only certain lines that contain a certain pattern. So let's say we got 100 lines. Some of them have this DRWX, and some of them don't. And we only want the ones that have the D. So what we could do is we could say ls-l, and that just gives us our output. We can use this pipe character, pipe it in the command grep, DRW, and now it only gives us that line. So if we just type grep and just run it, okay, well, it gives us, it's too smart. But if we type grep dash, it looks like it's doing nothing. But what it's actually doing is it's waiting for input. If you put a dash after command that's expecting input, that dash tells it to take the input from you. Or if not you, the command that you're piping to it. So if we let's see. Right, I need to pass it a pattern. So let's say rep hello. So if I say hi, nothing happens. If I say yo, nothing happens. If I say hello, it gives us hello back. So this hi, yo, and hello, those are the three things that I gave it as input, the three lines that I gave it as input. Those could also come from another command. And then that last hello is the output that Grep gave back to us. The only reason it's in the same, that they're all in the same terminal is because I typed in those characters, right? So we also have WC for word count, and we have head and tail. So I'll just show off those as well. So go back to LSL, those are all our files. So if we do ls-l and we say pipe it to head, won't do anything because I think head by default prints the first 5 or 10. So if we say ls-l pipe it to head-n2, telling it to only print the first 2 lines. Oh, okay. So we get the total 488 and the CLI demos line, right? These are the first 2 lines in our output. And so similar with tail, we type in ls-l, type the tail. It'll do nothing because tail's too big. And I think tail doesn't use -n. I think tail, you just give it a number. No, okay, it is -n. There we go. And that gives us the last 2, right? Get.odp and get.pdf. All right, so that covered redirection. We can also redirect to and from files. So, find my terminal again. So let's say ls-l gives us our directory listing, and let's write this to a file. And let's call it files.txt. Now, if cat is used to concatenate files, it's basically used to read files. So if you just want to know what's inside the file, you can type cat and then type in the file name. And that's what's inside our file, right? I can also do this for one of my presentation files, but it'll look really ugly because they're not text, they're other formats. So it's like cat or get.pdf file, and it's a bunch of PDF formatting information that is not human readable, right? So that's actually the raw content of that PDF file. And then we can also receive input from files. So if we type, let's remind ourselves what's in that file we just made. What do we call it? Files, yeah. So if we cat files.txt, that's what's in files.txt file, we can run grep drw like we did last time, and we can use this other angled bracket pointing into the command to take the input from this file. So we can say get it from files.txt, and it gives us that one line just like before. So what we did is we took the output of ls and we wrote it to a file, and then we read that file back into grep, and then grep operated on the file. So you can pipe from commands to other commands, you can pipe from files to commands, you can pipe from commands to files, and there's really no limit to all the different things you can chain together. So I have in my slides, you can have command 1, command 2, command 3, command 4. There's no limit to how many commands you can chain together. And you can combine piping in from files and piping into commands. So let's say we want to cat files.txt, that gives it as output. And then we can, let's see. Let's say we want to count how many PDF files we have in this directory. So like I showed earlier, this WC command, if we do man WC, it'll print new line, word, and byte counts. And so if we pass it this -l option, it'll print how many new lines, that is how many lines there are in some stream of input. So if we do ls-l and pipe it to wc-l, it gives us 7, right? Because we have 1 for the total and then 6 because we have 6 files here. So let's say we want to count how many PDF files we have in this directory. And we want to get it, let's say we don't want to get it from ls, but we want to get it from that file we recorded earlier. So we cat files.txt, there's all our files. So let's grep for PDF and pass it in the input from files.txt. And so that gives us these 2 lines with PDF files. And so we want to count how many there are. Well, we can pipe that to wc-l, and there we go, 2 lines. So with just 1 line, grep PDF from files.txt, pipe it to wc-l. That's our way of telling the shell to count how many PDF files are in this directory. All right, so now where we get to the real power of the shell is in scripting. And so, like any program, the shell can actually take input from a file or from another command. So remember, echo gives us whatever we gave it as input. So if we echo hello, it gives us back hello. So we can echo ls, it's going to give us ls. And if we pipe that to bash, it actually runs it. So what you can do is you can write a file. Let's see, vim script. So if I write ls, now let's write ls again, and then let's write echo hello. Those 3 commands in sequence. If we run bash, which is our shell, and we have it read from this script, it ran ls twice, and then it said hello. So that's where things get really powerful, because you can automate the process of running several commands in sequence. So let's see. And ideally, we don't want to have to run bash and then tell it to give us the input from the script file, right? Ideally, we would just run the script file and it would know to call bash. And so that's where this thing called the shebang comes in. And so the shebang is something that goes to the top of the script file and it tells the operating system what file to run. So if we edit our script file again, and we add in pound exclamation point, and then the directory to the program that we want to run. Now, I have to make it executable, which again, is a more file system concept that Dr. Vigali will go over. What I'm doing here is I'm making the script executable. So now if we type /script, now it just automatically runs it. We don't have to tell it to run bash because the script is what's telling us to run bash, right? And so essentially what that shebang is doing is it's saying, run this program, run /bin/bash, and take everything else in this file as input. So this is something that would never really have a practical use, but it's useful for demonstration. Is let's make a file called grep script, and let's have it run /bin/grep, and let's run grep hello. And so if we have these 3, let's make some lines. Let's say hello, hi, hello world, yo, and howdy. We do this and we make it executable. And we run it. So it actually runs grep on itself. So we get all the lines that contain hello. So that's the first line, right, with a shebang and telling it to run grep hello, and then hello and hello world. But those other greetings that we added in that file do not show up because they do not contain the word hello. So practically, the only way the shebang is used is to tell it to run some sort of script interpreter, whether that's bash. You can also write Python scripts that way. In the same way, instead of /bin/bash, it'll say /bin/python3, and then you can write Python code. So in scripts, we also have variables. And one other concept I want to touch on in scripting before going into actually writing more complex scripts is that anything you can write on a script, you can write on the command line. So once we get to for loops and if statements, you can do all that on the command line. So if I say for I in 0 through 5 do echo I, right? It prints out 0 through 5 on its own line. So that for loop, we can write it on the shell just as easily as we can write it in a shell script. Remember, a shell script is just reading all the lines in the file and shoving them into the shell, just as if you were typing them as a person. So on to variables. So the way that we set variables in shell scripting is we just write the variable name and we put an equal sign and we put what we want it to be. So I can make a variable named my name, and I can set it to Mark, and nothing happens. But now if we echo $, my_name, it says Mark. So the way that we dereference variables, the way that we access variables is with that $sign. We can also capture the output of commands into a variable. And the way we do that is with the $sign and then parentheses. So if we say ls underscore output is our variable name, and we get the output of ls wrapped in parentheses and a $sign, nothing happens. Now if we echo ls dash output, there we go. There's all the files in our directory. And then I think it's good practice to wrap it in quotation marks, just because there's a chance if the output has spaces in it, there's a chance that say only the first word will get assigned to the variable. I'm not 100% sure of the details on when specifically that happens, but if you want to be extra safe, just always put it in quotation marks. So quotation mark, $sign, parentheses ls. And then if we echo it again, there we go. And then we can also do what's called a string interpolation. So if we say echo, hello, comma, $sign, what was it, my name? It says hello, Mark. Now the problem, one problem that you might run into is, let's say we want to put an exclamation point after name. Okay, it works out of the box. But sometimes it'll actually take that exclamation point as part of the variable name. And one way you can avoid that is just by wrapping it in curly braces. In this case, it doesn't matter, but in some cases it might. All right, and we got control flow. So we got if, which an if statement, in case you don't know, it's a pretty basic programming concept. It's just we switch based on some condition. If the condition is true, we do one thing. If the condition is not true, we do this other thing. And then case works like a series of if statements. If you're familiar with a switch statement in programming, that's essentially what case is. For is a for each loop. So if you're familiar with kind of a C style for loop where you have a variable and then you increase that variable while some certain condition is met, for loops in Bash are not like that. It's just a for each loop. So like I showed earlier, where I typed the for loop right in the command line, scroll up to find it, right? It's a for each loop. So for each number I in 0 through 5, do something with I. But, I mean, you can use it exactly like that other for loop by using range expansion. All right, and finally we have a while loop. And a while loop basically does one thing, checks if the condition is true. If the condition is still true, it keeps doing that thing. So it does it until the condition is false. And test is how we actually use if statements. So if works based on what are called exit codes. And to show off what exit codes are, I'm actually going to go back to my shell instead of bash, because you see this prompt character, this lambda here, you can see it's purple right now. But if I type a command that fails, so let's say I type grep without any arguments, it turns red. And it's red because the command failed. But how does it know that the command failed? Every time you run a command, it'll give you back a status code. And I believe that's stored in the question mark variable. Yeah. So this command we just ran was successful, right? We told it to echo something and it echoed it. And now our icon is purple, which means it worked. So if we run it again, this $sign question mark says, give me the exit code of the last command that was run. So if we run it again, it should give us 0. And it does. So 0 indicates a successful command run, and anything other than 0 indicates that something's broken. So test gives us an exit code based on whether or not the condition is true or false. So if we say test, let's go 0 equals 0, that gives us a 0 exit code, right? Because 0 is in fact equal to 0, so it gives us back a successful exit code because that's true. And so if we say test 0 equals 1, it gives us a failure exit code because 0 is not equal to 1. So the way that if statements work is they work based on that exit code. So test was kind of a program that was created to generate exit codes based on whether or not conditions are true. So we can say if echo hello, now let me write this in a script. This is going to get a little bit messy. So if we do if echo hello, then echo hello again, else echo yo, and then the way we ended is speak. So what this script is going to do is it's going to say if echoing hello was successful, then echo hello again, and if not, echo yo. So if we run it, it says hello, and then it says hello again. So the first hello is we echoed hello, and we tested to see if echoing hello worked. And then the second is because it worked, we said hello again. So if I do that with a failing command, let's say, like before, let's say if just grep without an argument. Now, it gives us the error output of grep because we called grep and it failed, and grep is telling us the proper way to use it. And then it says yo, right? Because grep was unsuccessful, so the if statement jumped to the else part of the if statement, and so we just echoed yo. And then the shorthand form for test and shell scripts that you can use is just double brackets if you don't want to type the word test. They are completely equivalent. All right, so that's the end of my slides, but it's not the end of the presentation because I'm actually going to walk you through using a shell script to organize some data. But here's some further reading if you want to explore the command line now. There's a book called The Linux Command Line by William Schatz, and that goes very in depth, like A to Z, 0 to hero, how to use the Linux command line. There's a lot of stuff. I got a lot of stuff from this I got a lot of the content that I used in this presentation from that book, and I cut it down quite a bit. I think it's about 500 pages of just command line content. And then finally, explainshell.com. That's a useful site if you just want to type in a command and you want it to describe to you what each part of that command is doing. So like if we go back to the anatomy slide that I had. So if you typed in this command to explainshell.com, it'll tell you what ls does, it'll tell you what these two options mean, it'll tell you what the color option means, and then it'll tell you what your argument means. All right, so let's now write a script to organize some data for us. So if we go into this demos folder that I made, get some water first. So here's our data set. We have, I believe I made 20. Yeah, I made 20 because the first one starts at 0, the last one's 19. 20 CSV files of some data from, I don't know, some sensor that was collecting data for an experiment. So let's look at one of the files. So at the top of the file, it says which sensor it was collected from. And then we just got, some data fields. This is just an ID, and I don't know, it could be a temperature or something, and then a time and date at which that reading was taken. So each of these files, each of these files comes from a different sensor. So if we look at data 1, so data 1 also came from sensor A. Let's look at data 2. That one came from sensor D. So let's say that we want to put all these files into a directory based on which sensor that they came from. So let's start writing a script to see how we do that. So I already have one just because I wrote it to make sure it worked, but we're going to recreate it. So let's call it sort data 2. So first thing we need is our shebang, right, to tell which program to run in bash. So let's think about the problem. What do we want to do? Well, we want to do something with each file in this directory. So we're going to want to use a for loop, and we're going to use a for loop with the wildcard character that we saw earlier. So we're going to say for f, and this could be anything. It could be called file, or it could be called file name, or it could be called CSV. It doesn't matter. That's just a variable name. So let's say for f in star.csv, because we only want the CSV files, right? Let's say maybe we have some other CSV files that we didn't want to include. Well, then we could be even more specific and say data star.csv, right? So now let's just do a quick sanity check, and let's just echo out, make sure that we're going to act on all the right files. Because if we don't act on all the right files, we could break something. So let's just say echo f, and done. Make it executable. All right, so that just gives us all of the files that we are theoretically going to be operating on, right? So that's good. We're not going to operate on anything we don't want, and we are operating on everything we do want. So let's go back to our script. What did I call it? Sort data 2. So what do we actually want to do with this file? We want to sort it into a directory depending on which sensor it came from. And the sensor that it came from is always going to be on that first line, right? In all the files, it's going to say sensor A, sensor B, sensor D, whatever. So, did I just delete that line? Okay. I'm looking at the screen and I am typing on my keyboard. It's not going well. So let's think about how we can get that first line of the file. There's a command that gets us the first n lines of a file, right? It's called head. So let's make a variable and let's call it sensor. And let's say that that is equal to the output of a command, because we're going to run head. Head -n1, because we only want the first line, right? And we want to get it from f. So now let's make sure that, let's do another sanity check to make sure that sensors that we're getting are actually the right sensors. So if we run this, or let me go over. So we assign to the sensor variable the first line of each file, and then we just echo out that sensor variable. So if we run the script, all right, there we go. Sensor A, C, E, 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 A, D, A, B. We got all of our sensors now. So now what do we want to do based on the sensor? Well, we want to create a directory with that sensor name and then put the file into it. So let's mkdir f. So now, if we run it again, all right. Who knows what I did wrong? Let's make it interactive. Who wants to tell me what I did wrong? Check chat too. No one? Okay. So when I make dir f, what is make dir f doing? What is f? In our for loop. If we're saying for f in all of the files that follow this pattern of data something.csv, what is f going to be? When we echoed f, what did it print out for us? No one? It printed out each file, right? If we want to go through this for loop and we want to echo all of the f's, we just comment these out. Right? If we just echo f, f is going to be each one of these files, right? So my problem was that I was just making a directory with the wrong variable. I didn't want to make it from f, I want to make it from sensor. So now we run it again. All right. So there's a bit of a problem here because you can see we have one directory named sensor and then one directory named E, one named A, B, and C, and D. But we don't want that. We want directories named sensor A, sensor B, sensor C, and sensor D, and sensor E. So like I mentioned, quotation marks are what's going to save us here. Because by default, the shell will split arguments based on spaces. So if we say mkdir, let me type it out. If we say mkdir sensor A, it's not going to read this as make a directory called sensor A. It's going to read that as make two directories, one called sensor and one called A. So we need to make sure we wrap that argument in quotation marks so it only treats it as one argument. So now if we run it again, there we go. So it's giving us a few errors and it's saying that the file already exists, the directory already exists. That's not a big deal because we only want to create it once, right? It only creates it once. Now I got sensor A, sensor B, sensor C, sensor D, and sensor E. Let me just clean up those accidental directories we made. A, B, C, E, and sensor. All right, so now we just got our sensor directories. So what do we want to do now that we have all these directories for each sensor? We want to move the respective file into that directory. So now let's also delete that first line because once they're in the directory, right, we don't really need that header anymore telling you which sensor it came from because if it's in the sensor A directory, we know that it came from sensor A. So one command we can use to just delete the first line is a command called sed. And so sed stands for stream editor. It's an incredibly powerful command. We have nowhere near the amount of time to go into sed in depth. But if we type sed-i, that tells it to edit the file instead of just printing what we found to the output. And I believe it's 1D and a colon or semicolon, and then we pass it the file. That should delete the first line. And then we're going to make a directory for the sensor name, and then we're going to move our file into the directory. So let's see if it works. We got all of these different data items, and then we got sort data 2, so let's run it. All right, so it's complaining that the directories already exist, but that's fine. All right, all of our data's gone. Let's see if it got put into the right spot. All right, so now we're in the sensor A directory. We got a few files. Let's make sure they're all from sensor A. Actually, we don't know because we deleted the line. But we can kind of imagine that if it put all these files into the right directory, or if it moved all the files into all the different directories, and we can see that they're all in their respective sensor directories, we can kind of assume that that everything worked correctly. If we want to verify and make sure that they actually came from the right sensor, we could probably delete. We could probably verify. We could delete this line that deletes the sensor line from the data file, and just keep it until we verify that it's in the right directory. And then after that, we could delete all the different lines on each file. So that's the power of scripting. We can automate that. And let's say we get more data, right? Let's say somebody gives us 20 more CSV files in that same format. Well, we don't really have to do anything. We don't have to write anything new. We can just run that exact same script again, and it'll do the exact same thing for us. So that is what makes the command line so powerful. We got a question in the chat. Oh, okay, somebody did answer my question in the chat. Thank you. The meeting was kind of cutting out for me, so I'm sorry I ignored the answer. But yes, F is the variable holding the letter for the file name. Exactly, it's holding the name of each CSV file. So that is just kind of a brief introduction to the command line, what makes it powerful, why you should use it. Remember, it's powerful, it's everywhere. You can script with it, you can automate everything. You can automate like half of an office job with just the shell. And so I hope this is helpful to everybody. Any final questions? And in chat now, I think it's connected and it's stably connected. So I'll give a few seconds for people to ask questions in chat, and then I'll hand it over back to Dr. B. So jiggle the cable.
Yeah, there are no questions on the chat.
All right, I'll pass it back to you then.
All right. Thank you very much. So take a quick break and start in